Hello. హలో వినిపిస్తుందా ఇప్పుడు?
కొంచెం వాయిస్ ఇంక్రీజ్ చేస్తారా సార్?
చేస్తా, ఒక్క నిమిషం నేను కూర్చుంటున్నా. యాక్చువల్ వేరే ప్లేస్ వచ్చిన వినిపించలేదా?
ఇప్పుడు ఓకే సార్.
ఇప్పుడు ఓకేనా మేడం? మైక్లో వినిపిస్తుందా
సార్? వన్స్ మాట్లాడండి సార్, మళ్ళీ రీచెక్ చేసుకుంటాం.
హలో మేడం, కెన్ ఐ ఆడిబుల్?
yes sir. స్లోగా వినిపిస్తుంది.
ఫోన్ ఆఫ్ చేస్తే మీరు మాట్లాడండి, ఫోన్ ఆఫ్ చేస్తా, దీంట్లో మాట్లాడండి.
ఓకే సార్.
హలో హలో, వినిపిస్తుందా మేడం?
yes sir.
That is fine. Yes, okay, then we can proceed.
Yes sir. Wait for 5 minutes.
Yes.
హలో కిరణ్ సార్, గుడ్ మార్నింగ్.
గుడ్ మార్నింగ్ సార్.
నేను అంజేస్తాను సార్, ఈసీహెచ్ఓడి.
సార్ నమస్తే.
బాగున్నారా సార్?
బాగున్నాను సార్.
ఓకే ఓకే సార్, క్యారీ ఆన్, ఐ విల్ టాక్ యూ లేటర్.
యా షూర్ సార్. ఓకే, థ్యాంక్ యూ, బై. హలో మేడం, వాయిసా మేడం? ఓకే మేడం, మా ఆడియో నాది 100% ఉంది. నేను మైక్ దగ్గర పెట్టుకొని మాట్లాడతాను ఇంకా.
Good morning, everyone. A teacher influences generations, and continuous learning is a key to inspire excellence. With his inspiring words, it gives me immense pleasure to welcome you all for this faculty development program on advanced semiconductor technologies, enabling AI-driven, IoT-connected, and smart manufacturing solutions for Industry 5.0. Today's faculty development program provides an excellent opportunity to explore the latest advancements in semiconductor technologies and their vital role in shaping today's technological world. Now, it's my privilege to introduce our distinguished
मैंने आप ही नहीं.
Now, it's my privilege to introduce our distinguished resource person for today's session, Dr. Amireddy Kiran Kumar Sir. Sir is currently serving as an assistant professor at CBIT Hyderabad. Sir has accomplished academician and scientist with overall 13 years of experience in research, industrial, and teaching. Sir obtained his PhD in mechanical engineering from IIT Madras, specializing in metamaterials and ultrasonic imaging. Sir's area of expertise include non-destructive testing, robotics, image processing, material characterization, Python programming, artificial intelligence, and advanced manufacturing. Before joining academia, Sir worked as a research engineer at St. Gobain Research India, contributing to cutting-edge industrial research and innovative engineering solutions. Sir has successfully completed and led several sponsored research projects, published numerous research papers in reputed journals, and holds patents in this area of research. Sir has received several prestigious recognitions, including the Best Teacher Award, Young Faculty Award, INSC Young Researcher Award, and and to mention GYTA Award, presented by President of India. Sir has organized and delivered several AICTE adult faculty development programs, workshops, internships, and expert lectures on emerging technologies such as IoT, robotics, drones, Python programming, artificial intelligence, and advanced manufacturing. We are indeed honored to have such an accomplished researcher, educator, and innovator with us today. On behalf of the Department of ECE at MITW and everyone present here, an extended warm welcome to Dr. Amireddy Kiran Kumar sir. Sir, I invite you to kindly deliver your session. Over to you, sir. Thank you.
Thank you very much, madam, for the nice introduction. I'm really happy listening all these things from you. So let me share my screen.
So, just a minute. I request all the participants to mute your mics. Thank you.
Hope you all can see my screen.
Yes, sir.
Yeah, thank you, madam, for confirming. Okay, so I thought of showing some actually like exactly what is Industry 5.0 and applications of 2-3 images, but I am not able to figure it out. This is a new laptop. Last 2 months, I'm using this laptop. Previously, all my stuff is there in other laptops, so which was having some trouble. I cannot able to figure it out the data and all. Maybe somewhere the data is there, but I tried my level best to show how the industry look like, because I was working in industry last 8-9 years ago. So, and I went to really this industry 5.0 when it is started from couple of years ago we are hearing, but in industry we are seeing the same industry 4 to 5 revolution what is happened, and industry 5.0 we are hearing from last 5 years ago from France and China and all. So we really introduced this industry 5.0, and we really happened to see what could we can achieve best using all these sensors and IoT applications, and how much efficiency can be increased, and how industry really benefit out of all these sensors. That's the kind of industry 5.0 fruits. We are, I'm the witness. Have seen that even in the India, France, and China companies, especially in the manufacturing companies where I worked previously. So with the introduction, let me start fast. Uh, so this is the agenda of my talk today, and please feel free to stop me wherever you didn't understand or where you need more clarity is required. So you can ask, you can get the question to the coordinator. In fact, they can ask. At the end of the session also, we'll have the interaction and question answer Q&A session will be there. That time also you can clarify. Okay, so without further ado, I will straight away jump into what is Industry 5.0. So just previously I was telling actually why this 5 we are hearing. What is when it is started industry 1, 2, 3, all these things. So we are seeing from the world wars and all, uh, there 1, 2 completed and hearing frequently when the 3 can be happen, all these things like that. You might have familiar, that's why I taken that this topic. So similarly, this industry 5.0 means it is already completed all the 4 revolutions and all. So where we are in India, are we really talking about industry 5.0, but are we really implementing in Indian scenario this industry 5, all these things? We'll give a little emphasis on this and we'll take off from here. So industries revolution will be implementing all kind of resources and all. Previously industry 1 and previous industrialization started, so all manual things are there. So where electricity introduced and how little bit kind of parts can be taken care using material handling system, all these things until industry 3.0. So somewhere manual human intervention can be removed completely or few parts wherever it can be possible. So material handling system, where can we use systems like a robots or uh, take some kind of things to move the hard and harsh materials or something from the harsh environment and all. So really, Industry 4.0 is talking implementation of IoT with the industrial motors or sensors or even industrial machinery. So IoT, we can operate all these things. But in Industry 5.0, what exactly it started using of these IoT and sensors and interactive tools. So even we can control everything automatically. Like we are hearing that some kind of memory kind of alive and things. So if something happen, automatically shape remembering things. If you distort it and leave it again, it will regain its original shape kind of thing. So suppose if something happened in the industry, it will be stuck in somewhere and all. So it will be, you can control or you can remotely operate using the internet and uh, manual interaction kind of means wherever remote interaction I can say. So all these things you can correct the things and make it going to its previous condition or make it working condition. So that's where we can say it is industry 5.0. For that we need completely automation, elimination of human being or human intervention in wherever it is possible mostly. So and if something happen, it has to figure it out what could be the reason why the stuck or something it is not moving forward. So it has to immediately figure it out what is the root cause problem and immediately need to find out the solution. So in that way we can see the delay time or downtime things minimized. So that imagine that in industry if something happened in the, if you didn't manufacture in one day, so how much loss to the entire company. So we cannot keep put all the employees ideal without providing the resource or with because of something faulty machinery or some repair kind of things. And so that is why in industry 5.0 it is a very effective powerful tool for the manufacturing thing. We can revolutionary see the uh, that effectively using of all the resources and increase the profit or effectiveness of the plant. So in order to do all these things, we must see these kind of factors, human-centric manufacturing, and we can use the robots and digital things and all kind of IoT kind of applications, I can say, and some kind of predictive maintenance. So there is one more thing you need to understand what is maintenance is required in industry. thing, any machinery. But like you go for your servicing of your car or bicycle or motor, whatever it is required. So whenever you feel something problem, we'll go for servicing. So that is breakdown maintenance. So some breakdown happened, you are calling for the maintenance. But if you do that for every time, sometimes if you give your car for service, he may tell that it may need 1 or 2 days. You come back after 2 days and take it. So that is breakdown maintenance. Suddenly it failed and you are trying to repair it. But we cannot do that for in industry. Like I said previously, if you do that until that period, how the manufacturing will happen and what kind of work the people will do and how we can achieve the due date and targets, all this thing. So that's why we can do the continuous monitoring is required and maintenance is required. So predictive maintenance is something that we can predict something going to be happen by seeing some symptoms, early warnings, all these things, and we could repair it to avoid the catastrophic failure. So that for that we need to use a lot of sensors, all these things, and we can monitor every time to time, and we'll see how this maintenance can be happen. If something faulty signal we receive, and we can immediately call for the rectification and repair kind of thing. So that will take very less time to fix out or figure it out the problems, and that is called the predictive maintenance and so condition monitoring kind of thing, instead of directly doing to the catastrophic failure kind of thing, repair. So that is the thing. So in order to do all these things, we need to depend on only the sensor kind of. You can see the some just what is happening in industry 5.0, how human centric stable manufacturing is happening with the control of everything by implementing all the sensor. You can see sensors just taken from the uh, online. So just to show how the sensors are implementing, and I thought of showing, like I said, in industry how furnace and all kind of equipment and all there. So how many sensors are required to really see the condition of a machine, how it is working and all this. So we can see that. So temperature sensor is there, and pressure sensor, vibration sensor, vision sensor, and in the down you can see what kind of parameters can be monitored using these sensors, and force or torque sensor, position sensor, proximity sensor, environmental sensor, and there are a lot of sensors are available. And showing next half an hour we'll be talking about all these sensors applications, and we'll see next of how these sensors can be engaged. If possible, I can show. It is not hands-on session, but we can really see how could we see the simulations of all these things using the open source kind of thing. How can we connect or engage these things to work it? Uh, we can see the projects also, and I'm happy to say that in past year itself we introduced in 4 years ago, I think in our 22 or something, 2022, robotics and drones and all kind of all discipline undergo all these things. Then at the end they have to submit a project. Not really any assessment is not there, like a theoretical assessment, like regular examination, and only they could submit only the project, and they will get the pass as well. If fail, he has to repeat the entire thing with the next year junior. There is no makeup exam also for this. So this I think really help students to undergo all these kind of tools, and they will be familiar, and in industry or wherever they are working, if immediately they can find out which sensor will be useful and what kind of selection process is required and how to integrate. They may be exactly the programming and all, they may not understand or they may not know also, but they can figure it out when there is a need. So I can give one example here. Even when I working in the industry, like I said, in 2018, with doing completely inspection. You can see in imagine this kind of online monitoring is there, but when we are doing that conveyor belt is almost a kilometer length. So whether the component is moving on this ready component, I'm not sharing all the details of the manufacturing things and all because of the company's uh, thing. They cannot, they allow to reveal everything. So that's why I'm just telling. So one of the components we are manufacturing, and from the one end to other end it will reach. So the length of the span is almost a kilometer or 800 meters, you can say. So at the end, we need to see whether the component is ready or not, or means with the exactly manufactured with the good quality or not. We will do the quality test and all. So that quality test is completely manual. So for that, what they are doing in the traditional method, they take at least every 40 minutes or 45 minutes one sample, and they do the testing and all, and will see that the quality is good or not. After that, again they will take one more sample from one next 40 minutes cycle. So in between that, if something happened, they may not see that all the 40 minutes manufactured. They will select one or two samples and will do the test, assuming that that 40 minutes manufactured with a same kind of way. So one sample testing is enough, like that they are doing. And the testing is completely manual. I said it will take almost 20 minutes to 25 minutes of testing, and whether the component is manufactured correct or not, also it completely depends on the person who is doing the test. There is no kind of automation, or there is no kind of exact measurement whether how feature is checking all these things. So when we started working on this, and we thought of doing using online monitoring kind of thing, and even we can send the sample even not only in India, we can directly send the sample to the France and China and other US also, and within 10 minutes they can able to see once the results uploaded. We'll use the cloud thing, and they can download and see the sample whether how the quality all these things they can visualize all that, and they can see the results. So for that, we you can simply don't think that only one person can do the entire project in industry. There will be a lot of people will be there. You can imagine there will be even 50 to 60 people work for only one project in industry. One cannot solve the entire problem. So like that, in the IT team is there 4 5 members. They are selecting some kind of programming. They are concentrating only on the programming, and as a end user, we say that what kind of application is required and how to do that and all. So for that, we started using IoT and cloud computing, all kind of things, and we can use only Raspberry Pi camera, and we mount on one end, and it will be continuously capturing the figure every 2 seconds or every 5 seconds. How the timeline you can do. So we given the 5 seconds, it will capture and we'll see the quality. Then the person who will do the test like every 10 minutes, and he will keep the sample there itself, and again the tested sample it will capture, and it will compare how much percentage degradation is happening, whether we can qualify the quality of the sample, or if we can reject it a collect, or like wastage. So all the things it will be automated and programming. So for that, it may take 1 or 2 years. It will be achieved in 1 2.5 years and all, and it is implemented. So that's way Industry 5.0 things we can say. Like I said, in India, really we are implementing all Industry 5.0 in manufacturing. All I can say. That means in India, somewhere we are at Industry 3 point something. Not even started Industry 4.0 in many of the plants, because if we restructure the things and all, it will require large amount of things modification and all. It will not possible immediately. So that's where thing. But all new manufactured things and all, even somewhere near to Hyderabad and all, I can see really this industry 5.0 also implementing complete automation plants are there in near to Ramoji Film City and Fab City. So 3-4 industries. I usually take the BTech students also there for checking complete automation. So that's where why I'm spending all 10 to 15 minutes to understand the problem. Why should we study and why should we spend this 1.5 hour to understand this lecture and what are the takeaways and where can we use this in the future. That's the reason why I spent these 15 minutes to understand the problem. Hope you got the essence. Why should we understand this IoT and sensor applications, especially this my lecture, what I'm going to cover in the next 1.5 hour. So if you have any doubt, you can ask now. Otherwise, we'll proceed further. Hope everything is clear, right? Can you able to hear me, madam?
Yes, sir. Please
Yeah,
continue.
sure, thank you. Because I completely make it hide the screen sharing and only using my PPT to.
Okay, okay.
That's why I cannot see the chart box on the screen. So
No
that's
problem, sir. Please
yeah,
continue.
sure. Thank you. So now the next thing is in order to implement the industry 5.0 and do the IoT thing and see the really uh, see the problem elimination and kind of catastrophic failure elimination in industries and we really depends on the mostly on the sensors only. So these sensors are kind of MEMS, micro electromechanical systems or vision sensors and biosensor. There are a lot of sensors. I just show given the flavor of 4-5 sensors. So sensor fusion, all these are the mostly using in industry 5.0 application. So I can give the all this kind of sensors where we can use each sensor, how it will be, all these things I will show next 10 minutes. If we understand, then the next half I can show how to integrate the sensor using the any kind of Raspberry Pi or Arduino Uno or any kind of working model. So so before the starting this sensor, so like in order to understand the situation where we are in industry, so we can employ some kind of smart tool, I can say. We don't know whether it is a sensor or robot or whatever it is. We can say some small tool we can implement in the industry and it can capture the scenario and it will keep updating us. As a person, you can take the update or the status and you can take the judge whether take a call whether anything need to be stopped or anything continued or all kind of things you can take a judgment. For that you need to implement like I to capture that we need some vision sensors or some kind of cameras or whatever you can say that we can sensor. So it will be doing only the images or capturing things and all are figuring some are taking some input. That is sensor. But how a person somewhere remotely you are accessing all these things, for that you need main four elements. Like how a human being is there. Like human being, we are either using all our sensors. We have 5 sensors, right? So all these 5 sensors are interacting, are helping us to interact with the external world or to talk others or to get the things or to visualize the things, all these things. So like the same thing, sensors are one part. Remaining something you are feeling hot, immediately you remove your hand or you should take somewhere or you move away, all these things. How it will be? Judging by your brain is analyzing the information, whatever the sensor is giving, and brain is analyzing and giving the commands to us how to react. So the sensor information we need to process. For that, we need to have the microprocessor or controller. So here, like I said, Raspberry Pi or Arduino Uno or any of the microcontrollers, we can use it to integrate this Arduino Uno or any kind of microcontroller, I can say. That is exactly working or mimicking like our brain, human brain. So sensors are there and brain is there. These two are enough most of the cases, like vision kind of application. In order to react or to move all these things, how we have hands and legs, how we will go and all. So we can see somewhere grippers and kind of things will be there. So end effectors or grippers we can call, both are same. So there are like exactly our hands, how it will be used in moving and holding something and keeping one place to another. That is the grippers and all. And one more important thing, can anybody guess what is this one? We have the grippers like hands and legs, how the human being have, and we have the brain, how to analyze information, how to interact with the world, we have the sensor, and how to drive all these things, where we get the energy, that is called actuator or motor or batteries. So these are the four important elements that are required to run any of these applications. So hope you got all four important components. Then coming to the only sensor, because the topic or the title of the uh, today's topic is only for the IoT sensors and all how to interact. So I am concentrating on the sensor part. Like I said, sensor is the device which interact with the environment. But how, in what way it is recollecting or getting the information and how it will be informed. So I can simply say, like I said, if you touch heart thing, a skin is getting the information and it is processed through the brain is processed. It felt that it is beating heart and we need to immediately remove that. All these things is happening within fraction of seconds. I cannot wait that information from the hand, whatever we touch, from the skin we are getting the hot or cold or something, and reaching the brain and analyzing and coming back to the hand again, immediately remove it. So all these things, it is happening in a fraction of seconds. The command executed and we got the thing. So how the sensor part here working? So it is interacting with the physical environment or external world, getting some information and converting that information to the other form. That is a simple sensor, you can say. So sensor is a device which interact with the physical environment and convert one form of information to, especially like in the super, it will convert the entire signal to the digital readable format, like a digital or analog kind of thing. Mostly we will use digital, like a thing, or for continuous kind of thing, analog you can use. Either digital or analog way it will convert. That output of the sensor is always any measurable values which will be thing. So you understand what is sensor now. It can be heat or moisture or motion or pressure or any kind of thing. So like all these sensor, we can use the application for smart manufacturing or smart factories or autonomous vehicles or UAV, unmanned aerial vehicle, or you can see guide the vehicle without driver, or just, or you can command, and healthcare application, agriculture, so on. So lot of applications we can see implementation of the smart sensor. So smart sensor, when I say, it will be the entire system, including the sensor and actuator as well as the microprocessor. Without that, we cannot say a device. Because a sensor, it will only sense and how it will be processed and how it will be communicated. For that, we need to have the brain, that is actuator, sorry, microprocessor. To run all these things, we should have the battery or some power. That is the actuator. So that's it. Mostly we may not use the grippers or end effectors in all applications. Wherever physical movement or handling or moving one part to another part, there we can use the grippers and actuators or end effectors. That's all. So coming to the mostly using this proximity sensors, I can even show some the sensors mostly what kind of applications we can use. So the purpose of proximity sensor here is to detect the presence or absence of any kind of object, just to find or to trace the object. So the types of the sensors you can see, inductive sensors are there, capacitance or capacitive sensors and photoelectronic sensors, ultrasonic proximity sensors and all. These are the different types of proximity sensors. And you can use these sensors in different applications like conveyor automation, robot positioning, object counting, finding the object, or defect detection and all, or material handling, where we can use the proximity kind of sensor. So advantages are these sensors are non-contact operation we can use, are highly reliability and fast response time, and which will be available with a less cheaper cost. And temperature sensor, like I shown in industry 5.2 image, so where we can use all kind of sensors and that. So that sensors I am detailed discussing proximity sensors and temperature sensors. So where you need the temperature measurements and all, we need to use this temperature kind of sensor. So mostly in the previous case, thermocouples and all, that is on the old and traditional way, they will implement the thermocouples and all. Now present technology, they are implementing, instead of wherever you want to measure, you should put a thermocouple there. So if you want to measure in an entire room, like 10 to 15 places, you cannot implement all these thermocouples. Everywhere you should mount it and you should attach the autonomous system to communicate all these things. For that, we need a SCADA system and all. A SCADA system means it will collecting all the information and gathering and storing somewhere, and it will put it in Excel format or whatever the data you want, visualization, drafts, all these things it can do. So you need to implement this SCADA system and all. To avoid all these things in present situation scenario, they could draw a simple wire, waveguide we can say, again, wire which we will use it for drying our clothes, and same wire they will implement, and wherever you want to sensor, they will put a notch. So that is the temperature measurements, and not only temperature, they can measure the all other properties also. If it is drawing through or flowing through a wire or paint or any kind of how much paint thickness is that, viscosity, what is the temperature of the paint, all the things also can be monitored with the simple wire and with the only one monitoring system and all. So that is the recent things they are using like in industry application to monitor the rheological properties and temperature kind of property. I started showing this temperature which we developed in the things and implemented in the industrial application. So the pressure sensor, the third one is the things which will be used, these kind of MEMS or piezoelectric or capacitance and kind of thing, to measure the applied force or system, how much force or pressure is applied. Either it can be hydraulic or pneumatic or any kind of gas applied on this kind of element. You can figure it out how much pressure is applied on that. So that will be used pressure sensor. There will be different type of pressure sensors are there. Depending upon application, we can use. The ultimate aim of the pressure sensor is just it will monitor the amount of applied force or pressure or traction applied on that area or volume or surface. It can be measured. Then vibration sensor, either acceleration or any movement or any kind of vibration, we can use mostly using the piezoelectric vibration sensors. And accelerometers are there, MEMS accelerometers, which will be really piezoelectric crystals are little cheaper when compared to the accelerometers and all. But all these things are touch sensors, we can say. Or you should put a near to the actuator where it is vibrating and all. It can measure the amount of amplitude and how much deviation is happening. All these things it can measure. Then force or torque sensor, like pressure sensor, it can be even calculate the amount of force applied and torque applied on the thing. Mostly we can use it for the robotic applications and all. Then position sensor, So position sensors are mostly used in the making of these robots, drones and all, where we can exactly keeping the thing, or where exactly we are monitoring these things, how we need to move all these things to exactly trace the position. So linear encoders, rotary encoder, if we get the information, how best we can correlate the information, whatever we get the displacement. Let us say suppose in a room we are monitoring 4 5 locations, only the amount of some force or temperature or something. So each corner if we are monitoring, so one corner the temperature is 30 degrees, in other corner the temperature is only 15 degrees or 16 degrees. So it will be switch on that near to the AC, it will be around something maybe some 16, 17. So if it is a big room and the other wall is around 30 degrees and all, so if you are monitoring which wall is 15, which wall is having 17, which wall is having 30, all these things, you need to use the encoder here. So to trace that position, whether what that information where you are collecting to exactly mapping that things and all. Imagine some kind of this encoder. I'm giving the most example. We use this to measure the defects in the component. Imagine that brick or some kind of components we are manufacturing, iron or some kind of metallics or ceramics and all. That brick itself, the length of the brick is around 2 meters, 2.5 meters and all. Or iron ingots, it will be around 2 meters and the thickness is around half a meter to 1.5 meters. So inside some kind of crack or any kind of delamination or any kind of density variation or even foreign material, inclusion of any foreign material and all, if you scan it, you will understand that there is some defect. Don't know where exactly the location and all. If you use the encoder and from the starting, from the one end or left end, it will be around half a meter at a depth of 200 centimeter or 200 meter, something like that. So we can figure it out by using the different types of encoders, linear, rotary, and LVDT, and all different applications we can do. So vision sensor, like I said, most of the machine vision we will use the Raspberry Pi by images and camera, which will be having our high resolution image cameras or drone cameras, all these things. We will use it for vision for the quality inspection and finding the information in the required area. Then LiDAR sensors and all, we can use it mostly for the autonomous robotic applications and all. This will measure mostly for the light, amount of light it's carrying and all. Then the ultrasonic sensor, I will use this ultrasonic sensor as the case study, so I will take this separately. Then MEM sensors like accelerometers, gyroscope, pressure sensor, magneto sensors and other, we will use like a MEMS, like for shape memory kind of things I said previously. So all these are MEMS applications and all. Then gas sensors, which if you go to the all kind of most of the modern restaurants and cinema, movie halls, and all kind of this meeting halls, all these things. So these gas sensors are mounted. If you see some kind of smell or any gas detection leakage is happening and all, you'll see the alarm kind of thing. So they will see where exactly this gas is leaked, and only that place the alarm information can be immediately locate the thing. So whether it is a methane gas or any kind of hydrogen, nitrogen or anything, all that also you can see the variation and all also. So that is the use of that. And now modern application, even in the colleges, schools, everywhere you can see the gas sensors are attached. Humidity sensors, which will be figure it out how much amount of relative humidity is present in that. Even we are implementing this duct designing and all HVAC systems now, because it is centralized ACs are implementing in most of the halls and this most of them are meeting halls, move manufacturing, large complex shopping malls, all these things. So there where the humidity values checking and all, whether the AC effect is correct, controlling or not, any cooling effect is not there. So to find out all these things, we can install the humidity sensors and find the relative humidity at a particular place. Then current and voltage sensor to see any kind of electrical motors or like I said actuators and all. So to find the fault things or to monitor the things, we can use this sensor. Then RFID and NFC sensors, to tracking the things. If we implement this RFIDs and all in the inventory control, it will be easy. Where it is there and how much quantity, all these things, we can simply figure it out using these RFID tags and all. And even we can locate all these things also. So mostly we can use for all kind of assets. Just to put a tag and we can measure. So just to scan it and see whether, and even applications also you can just mention whether it is actively that particular asset is active or any kind of repair is required and where it is present in the service or in the inventory or in semi-finished or finished or where it is, all these things also we can update. Then biosensor. Mostly like you are now using the smartphones to check what is the BP and pressure, that PPS, all these things. So biosensors which will be used in the uh, health monitoring kind of things. You mostly everybody had a flavor or had at least visualized these sensors. So then smart wearable sensors like if you use the smartwatches and how much energy you are consuming, how much distance you are walking, all the things you are tracking using this only biosensors, which are wearable biosensors, I can say. So I just given lot of sensors and all, and what are the application, just a summary. I can show here what are the applications of each sensors and where we can use the different areas. I just summarized here. Anyway, I will share on these slides to a coordinator, so you can take it. Then, like I discussed,
Sir,
yeah,
1 minute to interrupt you. Sorry, sir. Can you once check around yourself? Some disturbances coming, sir.
some disturbance. Sorry.
Yeah, background noise is coming. Once check off it.
Okay, sure, madam. Thank you. Okay.
Yes. Yes.
Is it okay now?
It's coming, sir, actually.
Right now,
Yes.
where I
Now
am, it's fine.
it's
Directly, I'm speaking to the microphone to the computer.
but around someone is talking, those what we say, sound is a bit of it.
Okay, maybe.
Now it's okay.
Okay, yeah, you are continuously getting some noise.
Yes, yes.
Yeah. Okay. Hope
Okay,
it's
sir.
fine. Yeah. So like I saw previously, all kind of sensors what we used for the different applications. So all these type of sensors are only classified into two varieties. So like I said, we can have only two types of sensor. One is input sensor, and obviously you can guess the other one. The other one is output sensor. So the input sensor is the one we can say which will, these are the human sensors. I should have used this slide in the previous first second slide, I can say. So how we are figuring out or how we are interacting with the wall, and we should use the same kind of thing for the application to the motors and other things so that we can see. So if you implement these sensors and this, so it can be able to find. You can see this modern one car. So what is the battery status and how much fuel is there and what is the proximity when we are coming some vehicle, whether how to figure it out or how we are parking, how we are energy is there and how much water is stored in the when we use the wiper and all. Everywhere we have the different sensors are there to check the system effectiveness and all this. Just you can imagine that. So different kind of sensors are there to find different inputs. So like I said, all the sensors are categorized into two type of sensors. One is input sensor and output sensor. The input sensor is the one which can take the input from the surrounding and it will take the information into inform to the microprocessor to analyze the thing and all. So that is the input sensor. I'm repeating again. Input sensor is the one which can take the surroundings information, info, interact with the environment or external surroundings, and it will take that and will give or pass to the microprocessor for the analysis. So that is called input sensor. So example of that is rotary potentiometer. So, so rotary potentiometer is the one. Can you hear the same noise now? Hello, madam. I think now this
Yes.
one. Yeah, this is okay. So rotary potentiometer is the one we can use it to find the how much rotation is there, whether the rotation is clockwise or counterclockwise. To find that, we can use the rotary potentiometer. You can see the knob here. Just rotate it like this, it will be a counterclockwise, or if you rotate like this, it will be clockwise. How many turns it is rotating, all these things, you can see the internal, how much. This is the knob which will be connected to the circuit, and when you're rotating from here to here, it will be a counterclockwise, and when you're rotating like this, it will be a clockwise kind of rotation. So, and it will see how many counts it will be, that it will be. So we can say it is a input sensor. So these are the advantages of the sensors. Yeah. So the memory, you might have used the push button most of the toys wherever you are using. So just a push button which will be like as a switch it. When you push it, it will be the switch is closed like this. If you press it, so the switch is closed. Otherwise, if you leave it, then this will be disengaged and it will not work. So like a push button will be like a switch it will work. Like it will be also input sensor. When you press it, it will take the input. So the force sensor, like we discussed previously, it will be look like this, and we can use it for calculating the amount of force or pressure applied on it. The unit will be depending on your application. Either it will be kgs or kilograms, like grams, all these things, depending upon the application. You can use it or even newtons, all these things. Amount of force or pressure applied on it. So the application, it will be just like inside some smart flexible sensors are there. So it will just before using it, it will be calibrated. So like 1 kg applied, it will develop this much of resistance, and then if you apply 2 kgs, this will be like this, the response. Then it will be back calculate and correlation will be there. So automatically it will give when you are really using it, how much is the force applied on this. So light dependence resistor, we can say LIDAR, this one. So it will give me the amount of light, whether it is a dark or day or sunny day, how much is there. You can figure it out by using this sensor. Then rotary encoder, like I previously shown it, the working, you can see that the flip, you can, if possible, I'll take ultrasonic sensor and first simple LEDs and all, then ultrasonic, then I can show this rotary encoder also. There I discuss the working principle of this rotary encoder right now. Then triple axle accelerometer, it will be used to mount on the surface where we can find out the amount of displacement, distance, they know, we can count attack and all these things. Activity of just movement. Then joystick, we can just use it. Most of all the sensor smart watches it is having, maybe for giving some inputs, we will use the joystick. Toys might have played using the joystick and all. So microphone for measuring the sound. It will be, if you use, even I'm talking in front of the microphone, just it will be amplify the signal or sound signal especially, or you can use it to take the sound input. And this is the one microphone you can see which will be measure even for the ultrasound, infrasound, all these things, different application. So this one, it will be only for works in the audible range. So if you use the ultrasonic kind of thing, how to measure that? So you can use the ultrasonic sensor or microphone which will able to get the frequency above the audible range. That we call ultrasound, right? 20 Hz to 20 kilohertz, what will be? It will be audible range. Above that we call it as ultrasonic sound, and below that infrasound. And that I will talk during the ultrasonic sensor, and I will give the complete application and how to calibrate and how to integrate with the Arduino Uno also I will give. Then the next one is touch sensor. Touch sensor is the type of sensor, input sensor I can say, which we can use to record a physical touch or embrace on the device or subject. How we can just put it, it will like a switch also. Even if you touch it, it will be take input. Like we can use it our mobile phones or remote control, and once you press that input it will take. Then ultrasonic distance sensor, like I said, I will take in the previous case, it will be separated some case study. So you can see the ultrasonic sensor here to find the distance of an object. Suppose if the object, if you want to trace something, finding the distance between the two moving parts or two objects or any element is there, how much distance is there from your source or from your place. So you can use the ultrasonic sensor. So the working principle is simple. So it will be having here inside that piezoelectric crystal will be there. So inside that. So that crystal, sometimes two crystals will be used for receiving one crystal and for emitting one crystal. So emitter and receiver. In most of the cases, sometimes it will be used only one sensor. It will act like both transmitter as well as the receiver. But right now, whatever I'm showing here, it is HCS R403 or something, that sensor. So this will be used, each sensor that the calibration data will be there, means what is the range of sound and what is the distance it will be used, that kind of. Suppose if you buy something, you can see on the top how much force you can apply, where it is the temperature it will be sustained, all that thing. Like we can say data sheet and all. So this, depending upon the application, you can select that. So it will be used, the limitation, range, all these things, how much distance it will work, all these things, it will be mentioned here. Suppose if you take this, it will be having one emitter, that transmitter I can say here, you can see the T here, and this is the receiver, R will be there. So what is the purpose of emitter or transmitter is that if you connect it to the voltage or external power supply, so that piezoelectric crystal is just vibrating it. So it will vibrate, that means it is emitting the sound. Disturbance in the thing, it will be generating that will be the voice, that noise or sound. So that piezoelectric crystal is vibrating, that means it is emitting, continuously generating the sound. So that will be transmitting. You know that sound transmission requiring medium. You can see, yeah, it is clear. So this is the ultrasonic sensor, which will be the transmitter. You can see T is the transmitter and this is the receiver. So like I said, once you connect it to the circuit or you supply the voltage, the piezoelectric crystal, that is transmitter, it will keep vibrating. So it will be emitting the sound. So this will be the sound. So if it is there, nothing is there in front of it, like a obstacle I can say, or the object or obstacle. So if it is nothing is present in that, it will just propagating in the medium. So sound transmits in the media, and it will depend upon the media to media the velocity variation. So sound transmission velocity in the air is around 340 meter per second. 340 to 350 depending upon the moisture present in the atmosphere. So if it is in the metal, it will be different. Metal to metal, it will be varying. So that is the sound transmission. For that, we understand it will require a media. In the media, if nothing is obstructing or any object is not present in front of the thing, the sound is freely propagating. If you put any obstacle here, what will happen? Scattering will be happening. Like you studied in the school physics. Scattering means reflection, refraction, bending of the things at a edge of the thing. All that things we can say like a scattering. Simply you remember reflection, you can say, if you didn't understand this scattering. So if it is object is there, like in the object, if it is interact, touch the object and the reflections will come from the object. So the reflection will back travel to the emitter. Like here we have another receiver, so it will be capturing that. So now what essentially it is doing, the amount of traveling time it will be measured. So it is the moment if we switch on, the emitter is emitting the sound, it will be traveling in the media, and in there is object, it will be reflecting some sound or noise that will be traveling back to the source or the receiver. So that it will be taking the time traveling to the object and coming back from the object to the source. So t. So it will be capturing the distance to d. If it is the distance is this one to d, but it will be taking 2d after time. Simply I can say the sound pulse is traveling 2d to reach the source. 2d distance is traveling. So if you know the distance, if you want to calculate the distance, then you are capturing here t, how much time is taking when the sound is coming back. That t is available to you, and you know the velocity of this media, like I said, 340 meter per second. Then you need to calculate the distance d. So distance d is equal to speed, or v is equal to d by t. We all know that formula, right? V is equal to d by t. You can write here. Because spending this much time, it will be required to implement or write in the code. So v is equal to d by t, and we are interested to find this d. But we know the weight, v is equal to 340 meter per second I said, and the time t is capturing this guy. This guy is capturing whenever it is sound reaches to the receiver. So we know the t. But essentially, just I mentioned this D, how much it is traveling is 2D. So we can put 2 here. Then we want to calculate the D. D is equal to V over T, and we send this T also, 2 also here. Then distance, uh, the distance of the object D is equal to V by 2T. D is equal to V by 2T. That is the distance we can find out. So all are known things only. D we can known, it is a constant, and T it will be captured by this thing. So I'll just present little other sensors and all. Then I'll take this case to implement or to integrate with the ultrasonic sensor interaction. How it will be taking using the Arduino. I'll take it. So temperature sensor, I already told about this. It will measure the amount of temperature in the area present in the humidity, relative humidity. It will measure. It will be input sensor. Infrared sensor also same like ultrasonic sensor, but it will work in the infrared radiation range. The frequency only different. It will be also same. IR receiver is there. IR transmitter is there. Same. It will be transmit. IR we cannot see. Then it will interact. If object is there, it will reflection will come and it will again reflect. The T it will be captured, same principle ultrasonic of it. But it is also when it is reflecting from the object, it will also emit the characteristics of the object. That also this receiver will be captured. So in that way, we can also see the amount of temperature of the surface. Like if you go to the doctor, previously they will use thermometer. Now they are using the IR thermometer. Just flashlight and the amount reflection thing, it will capture the object surface temperature also. In that way, we can get the temperature touchless. So Bluetooth sensor, we all uses it to transfer the data and to send the images, all these things. So GPS module also mostly we are using to find out the things and all like it. These are all input sensors. So coming to the output sensor, like I said, by the definition of input sensor, it will inform something to the control. Now it will do the exactly difference, exactly opposite. The output sensor means it will take or capture the information from the Arduino or microprocessor and it will inform to the external world. That is the output sensor. Means the output sensor is the one which will take the input from the processor and it will give the information to the surroundings. Example is light emitted diode LED simply. So LED if you use it, if you switch on it will give the light. It will emit light which is output sensor. Like RGB, same LED we can use it for 3 different colors or red, green, blue can be get from the one LED. That is RGB. So buzzer, it will give you the sound output sensor. Loudspeaker, similar to the buzzer only. Then LCD display, it will only be showing the some display on the screen. Then motors, all kind of motors. Like we can say these are actuators, like I said. So different type of motors are there actually. AC and DC motors. You all know what is AC motor and DC. I'm not going to classification and not going to explain. Just for a simple thing, which will work the direct current. And AC motors are alternate current. And in the industrial field or in the robotic field, mostly we will use these batteries or DC motors only to the power the robots and all. Like a energy source, like I said, actuators. Most of the actuators are DC type only. If you use the AC type, you will get maximum amount of current and all, but controlling is very difficult. We cannot control the situation if we use the AC thermal. So most of the industrial application where you required high power and all, you may go for the AC things like moving AC motors for material handling system and all. Where it will be requiring the AC, but most of the, like I said, industrial robotic applications and we will use only the DC motor. So in the DC again we have the servo motor and the stepper motor. I can show all these also actuators also in action how it can connect and all. So like servo motor and stepper motor. So servo motor is the one we can use it for the power transmitting and rotation. So this will rotate from 0 to 180 degrees. One sweep is nothing but 0 to 180 only. It cannot rotate 360. There are servo motors which can give even full rotation 360 degrees also. But most of the things which are available in the market are 0 to 180 only. But servo motors are high precision thing. You can get the output exactly. Whereas the stepper motor, it can rotate in number of steps, and the steps you can control by using the step angle. That step angle theta is equal to 360 by n, where n is the number of steps. Either you know the number of steps or step angle, you can control the things. So it will rotate, like I said, it will be rotating number of steps like so, like this. It will rotate for a 360 degree. So if you use the stepper motor, you can avoid the inertial effect, like railway bridge and all there. So we can employ the servo motor and stepper motor, unmanned railway bridge and all. If the rail is coming and you need to start the gate and all, right? So there we can employ the stepper motor. All in front of all kind of gated communities and all, there will be some checking point will be there. So the gate will be closed when the motor is or vehicle is coming, automatically the gate will be opened and so for that the gate closing and opening to avoid the inertia. If suddenly opens and suddenly fall down, the inertia effect it will again come down due to gravity, it will fall down. So to avoid that we can employ the stepper motor. Right? If where we need exact precision and all, there we can go for the servo motor. So like this, these are the different outputs. There are few sensors I can say which will be used as the input sensor and output sensor. Both it can be work. Like some of the motors, it can take the input and again it will display also. Or it can take some rotary encoder is there. It will take and it will also give the amount of rotation and whether it is a clockwise or counterclockwise, how many rotations it happen and all that can be taken also from the thing. So it will give information also. That's why it will be input sensor and output sensor. Few sensors are only input, few sensors are only output, few sensors are combination of all these things. So this is the first introduction of different sensors. So before going to the second part, I'll take a pause here. If you want have any clarity, you can ask me now. Shall I proceed further? Hello?
Yes, sir.
Yeah, okay. So now I said we can use, we now first phase we understand what are the different type of sensors, what type of sensors can be used in industrial applications to get what kind of information and all. So now I want to show these applications, how to connect these with any of the smart system like a brain. I can say here I employ only the Arduino Uno. You can use either Raspberry Pi or even other Arduino. and other microprocessors which are available in the market, ESP32, all these things. Any of the things, the program and these things will be common. And even the programming language I am planning here using only C++, C++. Even you can use either MATLAB or Python or any other language, coding language, which will be equally works here better. But only thing is that how you are connecting, how you are making only differs for sensor. The remaining things are common, and the programming also language to language only the command, the syntax will vary. But what kind of thing you are getting from the sensor, how you are observing, all these things are common. Nothing will be changed. So with that, I will take first thing is like actually one of the output sensor, simple output sensor I shown is piezoelectric buzzer or previously LED I shown first. Whatever it is, same thing, both are same. Either buzzer or LED, both are work wise I am talking. Simple configuration, but only it will emit light, LED will emit the light and the buzzer will give the sound. Nothing difference in that as a circuit wise. And so if you take the piezo buzzer I taken here, so how it will look. So like this is the Arduino Uno. So I'm understanding here Arduino Uno micro configuration or the pin diagram. Otherwise I quickly take. So Arduino Uno is having mainly four main elements or more segments. So you can see this on the top right corner. This is the digital is written here. Digital pins are there. So 14 digital pins are available starting from 0 to 13. So these are the digital pin. That means if you connect your appliances or sensor here, it will give or take only digital pins. That means either zeros or ones, it will on or off. So similarly in the bottom you can see this analog, six are there, pins A0 to A5, six pins are there. We can use these things for continuous signal information. So if you connect your device here, it will be taking continuously. Unlike here either on or off, you can see all the intermediate ones. So these are the two main important things, digital analog. And you can see here one thing is there, this is GND, ground. So there are three ground pins, one is on the top and two are here. This is the ground pin and this is the ground pin here. So these are the two ground pins, three ground pins available on the thing, that will be negative things we can connect, or ground pins we can connect. And the other important thing is power thing. So we can use this Arduino Uno to power up to 5 volts only. Even we can use 3.1 volts also there, but mostly maximum power we can get it is only 5 volts. So we can connect, if you want to use 5 volts, we can connect to this pin. So these are the main important things, and we can use the USB connector also to engage with our PCs or computers. So these things is required before moving further. So let us take, this is the piezoelectric buzzer, which will be having two pins here. One is positive, you can see this is the positive pin, anode, and this is the negative pin, cathode. So we are using the breadboard here. Without breadboard also you can connect, it is up to you. So when you use the breadboard, you need to understand the structure of the breadboard. So this is the one part up to this is the second part, this is the third part, and this is the fourth part of segments. You can see that four segments are there, one line, this is the second line, this is the third line, this is the fourth line. These four segments are there, and you can see these first and fourth segments, minus plus is written and minus plus is written. That means this line is wherever you take, it is horizontally connected backside manually. Sorry, backside it is horizontally connected. So if you take either this pin or this pin or this pin, anyone if you connect it to the ground pin, all these will act as a ground pins only. These are all same, I can say, horizontally interconnected, negative, or this is positive. Similarly, 1 and 4 are same. And coming to the second and third segment, these are vertically connected. So this entire system is one pin only. If you connect this pin to the pin number 0, that means it will be taking the digital input or output 0. All are same only. 1, 2, 3, 4, 5. All these 5 will act as a single pin, like that. So these second segment and third segment are connected vertically. So like that it is arranged, the breadboard. So now we want to connect to the breadboard, introduce the breadboard and take the piezoelectric thing. Just it is having 2 pins only, positive and negative. I said without using the breadboard also we can connect. So directly this negative pin we need to ground it, and positive pin you can connect to any of the digital thing, or you can use analog pin also for continue, but I am taking the digital. But if what is this? So this is the resistor. So we need the resistor to safeguard the electrical appliances to avoid the excess power transmission, that we know. So we can select the resistor and all. So that means positive end of the appliance, either LED or piezoelectric crystal. We connect one terminal of the resistor. Terminal 2 of the resistor will be connected to any of the digital or analog pins. That way the circuit connection is closed. Simple. Then coming to the program, every program is having two parts. So this is the first part and this is the second part. So first thing is void setup is the main part. Only pin configuration. How you connected this this sensor, how you are connected to the brain of the thing, or how you connected to the microprocessor. That way your description will be the main part of the thing. That is the first part. That we can use the void setup. Then coming to the loop part, that is second part. The loop part will be what action you want to see, mimicking that repeatedly. That you can say it is the loop part. So that is the second loop. So void setup. So in the void setup, dummy code will be always gives in that. So like I said, I forgot to inform. Like I said, it is the open source. Tinkercad we can use it. I can directly take to the Tinkercad instead of showing this. So next half an hour is there. I'm just going to share my screen. Can you able to see my screen now?
Yes, sir, it's open.
So in the you can go to the Google and type TINKER Tinkercad. So you can see the Tinkercad. Can you see the Tinkercad, madam? Hello, madam.
Yes, sir.
So what you can see now, Tinkercad screen.
Yes, it's visible.
Okay. So once you see this, open just go to the Tinkercad and click on this login. So you log in, then go to the personal account, then use sign in with Google. If it is already open your Google account, it automatically will take you, or else you need to select. See, so I need to select one of the email ID. So whatever the email ID, select the email ID, and same password will work here. So your email ID, and it will ask the password. Since my email is open, so it will not ask. Otherwise, it will ask your email ID, and you can see your name here. So that means you are entered here. So here you can go to create. So there are three ways you can create the things here: 3D design, circuits, or code blocks. So for kids and all in the schools, they are teaching these code blocks and 3D designs and all. So I'm directly going to the circuits here. We are going to make it circuits. So we have to go to circuits here. So once you click on the circuits, so this is a working place here. And if you see this, you just click it, you can enter your title. So first experiment, or what is the title of your thing, or what is the name, you can just out click, click on outside, you will get that name will be there. So this modification should done before itself, before starting the experiment or designing something. So since we selected the circuits, so we can select this. So this is the working place I said. So we need to use only for modifying or drawing all these things, this place. So coming to the left side, this you see the search option, this is the library here. So the library will be available. You keep checking the library, what are available in the library, or if you know already what is required, just type it and LED. Get it. So if you type it, LED is there. If you take that, just how to do is that drag and drop it in the workplace so that it will be used readily available for you to work on it. So take that, drag and drop it to the workplace. And to modify that, what are the parameters are available, you can see that. So this is the LED, it is having only one variety, that is variable here is only color. So what color you want to see, that you can select. If you select suppose green, automatically it will turn to the green. If you select orange, it will turn to the orange. Only one parameter I can see this. So that is the variable. Or else if you see that resistor is there, if you type the resistor, so this is the resistor. So if you see that the variants are resistor, that is the name, and the resistance value. You can give the value whether how much is required, whether 100 or 200, suppose something. And even the variable is here the unit, whether what is the resistance, ohms, pico ohms, mega ohms, or kilo ohms, all that thing. You can select the ohms and all. So like that you can do. So now it is 200 ohms. If I give 400 ohms, this is the thing. Or if you want to select, it is kilo ohms, whatever you want. So you can select. And for the selected object, you can see this is the just rotation. This one. So you can rotate that object even if you select that object. And this is a flipping. You can flip it like a mirror image. Or you can rotate it. And you can use these lines to draw this one, and you can use the color to make it if you want to see that. So for lining, you select the color and just draw that, automatically it will enter. If you press enter, it will stop there. Connect somewhere, escape or enter, it will be there. So if you want to turn that, even you select the line and you can go to the other color and press enter. It will automatically turn into that color. So like that we can connect the circuit. So really for this simulation we don't need any kind of instruments with us, and we don't need any this cables. We call this as the jumper wires. So like that we can connect. So like I say, simple example, we need Arduino Uno. Just drag and drop the Arduino Uno, and already I have selected this LED, and this is the resistor. I selected the resistor, and I am going the first example without using the breadboard. So I said LED is having two things. Like I said, buzzer. I'm checking here LED so that you can see the both of them. So like it is having only two pins. One is cathode and anode. How to see that? If it is online, you just put a cursor and it will automatically give you the anode and cathode. If it is offline, the longest leg is the anode one or the bent one. That is the longer leg. So anode. So how to connect the anode? Any of the analog pin. So I can select and connect to the analog pin T6. Escape it will be. Then cathode, either you connect anode or cathode end to resistor. Without resistor, what will happen? We'll see. So we connect this to the ground pin, right? So cathode will be connected to the ground pin, and the ground we can select it to the blocking color. Like that. Now cathode anode completed, and going to the code here. Click here the code, and code is having three things: block plus text, and text. Only select the text. Then continue. So this is the dummy code is already available. Just you need to and check that. Or if you know everything, you can see. So pin mode, pin number, comma output. I'm not telling these things because it will be completely 1, 2, 3 full sessions are required to give the entire commands and all. So pin mode is connecting which number. So this is the 6th pin number, 6, which is reading as output now. So this is pin mode, pin number, comma, input or output. So here it is output, already the dummy code is mentioned. So which pin number? It is 6. Then digital write pin number, comma, high. That means it will be high. Which pin number 6 will be high with that delay time. This much time it will be high. That pin number 6. Then the same pin number is low for the delay. This much time it will be off. So if I see this delay is reducing, so off time will be reduced, on time will be okay. So I can put start simulation. Then something happened. It is giving the warning. Why? So if you click on the warning, it is showing something. Current through LED is only 22 milliamps, while recording maximum is 20 milliamps. So unable to see. That means simply it is showing that you are giving the maximum power which the LED cannot sustain. So for that, to avoid that, stop this. You should use this resistor, and resistor other end. You should connect it to the that thing. So that way it will be safeguard. And how much amount of thing we can, that also we can select. Like V is equal to IR, it is already given this. So just now once you put the cursor, it is giving 20 milliamps. So V is equal to 20, I is equal to 20 milliamps, V is 5 volts we are getting from this. So we know that, I know that, R we should calculate. V is equal to IR from something that we can substitute here like this. So if you get more than that, it will okay. If you give less than that, it will again blast that. Simply I'm just guessing it widely. V is equal to IR, R is equal to we can calculate, and that I'm giving little bit extra. So then start simulation, it will be glowing according to the code. 1 second it is on, half second it is off. See, 1, half is low. I can play around like this. 5 seconds on and 1 half second it will be off. So again starting. So see, 1, 2, 3, 4, 5. Then 1 second, half second it is off. So like that you can see that how it will be connected and all. So like that you can see the only thing is you need to understand the pin diagrams, how these pins are there and how to connect this, and need to be know some little, remember, for 10 to 12 syntaxes so that we can engage all kind of sensors. And nowadays you have all the AI tools, no need to remember anything, just start this environment which will be using, how to use it, then get the code somewhere, you can copy and just you can directly paste here. So select everything and you can put the entire thing here, whatever you copy. Just to see that the code is errorless and just debug it. Anything is there, just correct it and you can use it for your application. So like that you can use all these sensors. So this serial monitor is something you can see some output. In order to continue this thing, you should transfer the amount data. So here itself we can mention in the main part, we need to use how to communicate to the serial monitor. Serial dot begin will be used. Begin. And it will be having only one argument, and like I said, it is C line, C++, every line ends with the colon except if or else conditional kind of. So here you can give that baud rate. This is having one argument, like that argument is having or how much bits per second is transferring. So 9600 I can say maximum, I can serial dot begin, that will be communicating. So that if you want to see here serial dot print, println. So at this time it is on. Now you can use the same thing when it is low. It is off. Let me check. That's it. So something. So here it is showing some error wantedly shown. If you have any kind of thing, so serial was not declared in the scope. Suggest alternate. S is the capital. So that's why if you have any error, automatically it will suggest. Again start simulation. It will be again showing. What is the error? Can anybody tell? Here every line ends with the semicolon I said, but I didn't include the semicolon. So these are the two semicolons. So the function void loop before taken, error except expected. The semicolon is like this. So you can put the serial monitor. See, it is on right now. The moment it will go off, it will show off, on, off. On is maximum time, off is very less time. So that's why you can frequently see that how it will be vanishing. So like that you can play around here. Because this will be useful for the rotation, whether clockwise rotation or counterclockwise. you can see on the screen. So like that, I can show. If you click automatically, this will be saved here. No need to save. Then if you want to reuse on the same thing what you worked on the previous case, you go here, you just, there are this many things. You click here, all will be, the list will be shown here. So this is what you worked a minute ago today. So, so you click here, select this. If you want to reuse it, select the time, automatically it will come here. Then if you want to see the pin diagram, you click here. This is the pin diagram. Then this one you can download as a PDF. If you click that pin diagram, you can download that PDF and it will be there. You can send it to your email and you can use that pin diagram for that experiment, so that any errors or anything you can be able to see that. So that's where you can see this thing. So if you want to see this, you can take a screenshot, and this is what zoom fit. If you click it, automatically it will be there. Suppose if you move that down and up, then sorry. So it went out. So if you click automatically, it will come to the zoom fit. So like that, you can see that. So if you click automatically, it will save. So this is the glimpse. You can use it, the open source Tinkercad, to select different kind of sensors and how it can engage. Like I said, ultrasonic. Say before that, I can go for this. So things, if you think this Tinker, this I was using almost 3-4 years ago. So now you can see this is the 3 LEDs traffic light simulation. So 3 here used. This is what breadboard is used here. So because 3 LEDs are there, I need to connect the 3 ground pins. So one ground pin I connected here, and like I said, if you select here, automatically entire line is highlighted. So the entire line will act as the ground pin now. So you can select these other things. So this all the cathodes of the LEDs are connected to the ground pin, and anodes. Previously I connected the cathode end to the LED, this resistor terminal, but right now I am connecting to the anode. Does that make any sense or any difference in that? You can also check. I used to ask that we should give the scope to that practice what we are doing, so that you can experiment it and you can learn, so that you never forget. So whether you connect it to the terminal 1 or 2, to any of the cathode or anode, the entire this circuit will become resistant. Sorry, in series connection. So in series connection, how the resistance will be added? Resistance 1 plus resistance 2 plus resistance 3, so and so, is equal to equivalent resistance. So that's why it will not make any difference. Otherwise, if it is a parallel, 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3, so and so. So that time it will make a difference. So since it is connected in the series, this entire loop is in series. So that's why whether you connect this resistor to the positive end or negative end, that is anode or cathode, doesn't make any sense. So in that way you can connect. So you can go to the code. You can see that pin mode is one time that, but we are using 3 pins. So I connect, write that same 3 times, 2, 3, 4. Then pin number 2, 3, 4 is connected to the 3 different LEDs. So I use all the 3 are outputs. Then digital write pin number comma high for traffic. Red color will be 2 minutes, or 2 seconds I can say, and other color will be only 1 minute or 1 second. Like that you can take difference, but when you on it should be off, low, on, off, on, off. On, off also will work, or 0 ones also work. So if you start simulate, you can see that it is red, orange, green, red, orange, green. I am going little bit fast so that because one LED already I spent time, so you might understand that. That's why I'm moving this little faster. If you have any doubt, you can ask. And you can also, this I said it is open source, nothing is required, just you have your email ID and 18 years plus. That's all, it will work. Everybody can use it. So you can see that ultrasonic sensor, how it works. So think of this. I spend little more time here. So come to the ultrasonic sensor. It will be having 4 pins. So how to connect that 4 pins and what are that we need to understand before making to the circuit connection. So you can see that these 4 things, like I said, HCSR04 is the model of the ultrasonic sensor. This is the transmitter and this is the receiver. You can select your ultrasonic sensor. Ultrasonic distance sensor means this one. Just drag and drop it here. It will show like this. And if you click it, only the name is nothing else. These are the 2 things are available. No variable is here. So this is the power source. VCC is the power. You connect it to the 5 volts. Then this is the trigger pin. You connect either input output. Echo pin you connect to the input output, and ground pin automatically you should connect it to the ground pin. So I am repeating, power pin you connect to the 5 volts of the Arduino Uno. Trigger pin you connect to the any of the input output sensor. Echo pin any of the input output sensor, and ground pin to the ground pin of the Arduino. But we need to say differentiate here, trigger and echo both cannot be input or both cannot be output. One is input and one is output, because the echo pin, it will be capture your reflection from the object or obstacle. This trigger pin will be capture your, it will be transmitting the ultrasonic sensor in the atmosphere. So it will be continuously emitting. This will be input and this will be your output. So that way basic difference we should differentiate. You can put it nothing wrong. So like I said, this we connected to the 5 volt, VCC connected to the 5 volt, you can see, and trigger is connected to the pin number 2 and echo is connected to the pin number 9 and ground pin connected to the coming to the code. So I need to say here the you forget all these things, input float, all these things that will come later. So like void setup, and I want to communicate to the serial monitor, because whether the distance is in centimeter or inches or anything, I want to see that in the screen, on the screen. That's why I'm using the serial dot begin with the baud rate 9600 bits per second. Then coming to the loop, pin mode is the trigger pin, it is the output pin, digital write trigger pin is high. So the pin mode of the trigger I am using as the output pin. Echo pin I am using here as the input pin. So echo pin I have to use as the input, which will be taking the input, so that it will take the time t. So once it takes the time t, the time t is equal to pulsing of the echo. So echo is capturing the information, that is time t. So that time I am calculating the distance. dcm is equal to like v velocity 340. I said 343 I am taking here, meter per second I am converting to the time seconds and distance in centimeter. So this is centimeter into time, that time t is here. If you put here t, it will be taken variables. These are all variables and all, you know, this case sensitive, you should use as it is, then by 2. That is the distance. That distance I'm converting to inches by multiplying or dividing, you know, all this thing conversion. If you don't want, you just show only in the centimeter. That is up to you. So that you serial dot print or println that distance in centimeter, that information. You know how to use this string format and without string. The string format, it will show as it is. If you didn't use the string, it will give that information, that value. So DCEM is the value stored in that distance. Whatever the calculation comes here, that will be stored here in this variable. That value only I am planning to print it. If it is here, if you use this string format, asterisk, these two things, it will be as it is, it will display. Hope you all know these differences. You know better than me these programming languages and all. So then if you start simulation, something is there, you can click here, click on this, so you can see the distance. This is the object, even you can play around. So this is the object, and that object is around a distance of 139.5 centimeters from your source, and if it is the inches, 44.9 inches. This is the actual distance, but as per your calculation how much it is there, you can see that also. You can see on the serial monitor. So the distance here, it is showing 54.82, 54.9, it is 82 inches, same. And 139.5, 139.03 is the distance in centimeter. And that way you can see, if you click it, that you can see. Then I move my object here, nothing is there. That means it automatically turns into red color. That means out of range. So this will be checking only from the around 6 centimeter to certain distance. Outside, other than that, it won't check it. That is blind spot. So that way you can see that. So this is the working with ultrasonic sensor. Even rotary encoder also you can use it, and you can rotate that whether clockwise or counterclockwise. You can see what not all the motors, select things, whatever is available in the library. I can show these things. You can use it. You can even use the potentiometer in between that, or push button in that. If you press the button only, it will work. Or you can use the display segments like LEDs, LCD screens, and photo resistor, soil moisture resistor, everything. You can take it try. If you have any doubt, you can ask me now. I'll stop it here. Meanwhile, you can take to rotary encoder. I can show you servo motor and stepper motors and so this code is required here. This is having only 3 pins. You keep ground, you can connect to the ground, signal to any of the digital pins, and this power you connect to the 5 volts. That's all. Simple. Then, like I said, it will rotate only 0 to 180 degrees. That also you can see on the screen monitor. If I didn't use the serial monitor here, in the code I should mention how to communicate, and the main serial dot begin with the baud rate, and in the loop I have to see how much is this rotation of these things, then only it will show. So you can see that how this motor is rotating and all. So yeah, it's your turn now. You can ask any kind of clarity required or anything. I'm very happy to answer all your queries.
Hello.
Yes.
Hello. Good
Yeah.
afternoon, everyone. First of all, hello. Can I hear you? My
Yeah.
voice is
Yeah.
audible to you
Yes.
also? Sir, my name is Neelima, sir.
Yeah, ma'am.
First of all, I would like to extend my sincere gratitude to everyone, sir, for conducting FDP program and also eminent speakers also, sir. Sir,
Thank
today
you.
you explained very well all types of sensors and also like Tinkercad, everything, sir. Sir, my question is belongs to in health sector, sir.
Hmm.
Like in the year of 2020 2021, we all I mean we all affected by the coronavirus, sir.
Hmm.
Now I heard so many times Ebola virus and all, sir.
Hmm.
So all these can't we find out earlier all these viruses are going to attack to someone else by using all these sensors, sir? By receiving any alarm or else a vision or any sensor, like that, sir?
Yeah, it's a good thing, because if somebody should have tried to monitor that, then only they can able to get it right. If suppose you are in the class, somebody is hitting you or somebody is poking you, you can able to see that. If you kind of in that situation, suppose if you didn't notice that he suddenly put slap you or something, we don't know that, right? We cannot expect that. So nobody would have dreamed about that these kind of things are going to affect or coming to our daily life, or we are going to affect with these things and all. So mostly they might not put efforts to find out that things and all. So maybe that thing, or even after affecting such situations, we don't know why it happened and what kind of things are causing that, how to escape from that, how to find the solution. We need to, because a lot of people worked about that. I mean, I'm talking about the development of the uh, vaccine, all these things, how much time, how we are this. The same thing may happen tomorrow, something will come. We don't know that. So with the available things, we can able to find only certain extent, but a lot of things are there, we cannot notice everything.
Okay, sir. Okay,
Yeah.
sir.
Yeah.
Sir, one more question, sir.
Yeah.
Sir, in the same question related to like in the transport, traveling, sir.
Hmm.
Gradually, road accidents are increasing, sir. Like one car is coming, going to hit. One car is going to hit someone else. How to prevent road accidents by using AI or else these sensors, like
Yes, like I shown the proximity sensors. Nowadays, unmanned vehicles are coming. Even you can see driverless vehicles are also running. Even in our present right now, I'm in IIT Hyderabad only in Pihan. They also developed, and I think yesterday this in charge went to France to showcase their autonomous vehicle in the conference somewhere. They got to show that Russian or some France government. So that all kind of sensors if you implement, and you need to have the monitoring system. There is something coming to near, automatically it will display, or even some if you implement alarm kind of thing, even you can get that somebody is coming to near or approaching you. You need to stop it, or you can guide left, you can go right. All these things are there, but all these things are very good and have very good for research and for discussion like this FDPs and all. But have we really put that in Indian road scenarios and all? It may take even lot of time. We cannot even now see that how many of us are following really the traffic rules on the road.
yes, sir, exactly, sir.
So
Yes,
even
sir.
though it is near, definitely we should see if you see the school bus, the distance should be something 8 meters or 7 meters, you approach like that. But even we are going near to the bumper and we are dash close to that, because everybody in rush in the morning, so nobody will follow that. So in that situation, in that scenario, we cannot implement all these things. That's the thing. But if you see such if it is like this remote areas and all, definitely we can implement. Even we here we use this that autonomous vehicle, driverless vehicle, that the entire programming they will make. So within the speed it has to go, means it will go. If somebody comes to the front, it will stop it. Then if the clearance comes only, it will start again. So like that, it has to give the coordinate mapping and how to give all that sensors and all. Definitely it will work. But I'm saying it will work for only limited situations with the very small application kind of thing. But
Yes, sir. Yes,
like
sir.
your question, we can definitely know what is coming, all these things. That's why most of the situation very easily people are using the cars and all with the all cameras and all mounted with the parkings and all. So you can turn on the back camera and without any person help, you can easily park it and all these things. It
Yes, sir.
all,
By using vision sensors
yes,
and all. Yeah.
exactly. Yes. Yeah.
Yes, sir. Sir, now you explained Tinkercad, sir.
Yeah.
My know, sir, Tinkercad is you. I mean, you explained even programming code also, sir.
Hmm.
My know, sir, Tinkercad is using only for like I mean, mechanical department. I mean, motors and all, or
No,
else
no, no.
it is.
For
Um,
everything you can use it. This Tinkercad, like I said, blocks why I shown. Even for the LKG to now international schools and all. Even my kid in international school, they are using the Tinkercad for the block diagram. They can draw some 3D images and some kind of thing. So this is freeware, so you can use everybody. So the school people are, even for you first second standard itself, they are drawing some kind of images, some kind of cartoons, some kind of developed things and all, so they can use it. So we are not aware of such things. So a lot of things are there in and around us. So we can use these things for anything.
yes, sir. Sir, in the beginning of the presentation, you mentioned the topic name semiconductors for AI, IoT, and edge computing, sir.
Hmm.
Uh, may I know, sir? I mean, what is edge computing, sir? I don't know. I don't know. I don't have any idea, sir.
Yeah,
That's why
that
I
is
asked you.
also there. It is in my slide. I didn't go that because at the time is the constraint. Like I thought of showing all the things, so I didn't go
Okay.
to that thing and all. So edge computing is something like we like I just give some just example to understand that. So a lot of research is going in that, and I'm also not sure in the complete programming part of all these things. I'm just doing only some small delta x only, just to use for different applications and all. So something like here you can see edge computing is like digital twins and all. So that means something happened, you can in somewhere you are able to see immediately, get certain information, and with your small changes you can suggest certain things, and that can able to adapt that system, and it has to have that leverage to implement that small changes, and it has to work. So that is what the meaning. That means something happened to the industry, some sensor is not working or something. You can able to control remotely and you make that to work. That is it.
Yeah. Thank you, sir. Thank you so much, sir. Thank you, sir. Thank you, and all. Thank you, everyone.
Thank you, ma'am. Any other question?
Any
Hello?
other questions?
I think if no other question, we can stop the session here. So I'm very happy
As
to.
we conclude today's insightful and enriching faculty development program, it's my privilege to propose a vote of thanks. On behalf of Department of Electronics and Communication Engineering, MITW, I express our heartfelt gratitude to our esteemed resource person, Dr. Amireddy Kiran Kumar sir, for delivering such an informative and inspiring session. Thank you everyone for being a part of this faculty development program. The feedback link will be shared in the chat box in this Zoom link as well as in the YouTube chat box. Kindly take few minutes to fill the feedback form. Once again, thank you all. I request everyone to switch on your camera so that we can take a group pic.
ఎట్లా చేయాలి ఇప్పుడు
Thank you everyone. Have a wonderful day ahead.